Today's lesson is all about polymers. Polymers are large molecules that are made by linking together many small molecules that are called monomers. We add together these monomers by completing addition or condensation reactions. Chemists have discovered many different types of polymers with different characteristics by changing up the monomers and the types of linkages used. Polymerization is a process used to create polymers. Some polymers exist in nature, but many of the polymers that we use are synthetic or created through chemical processes. Addition polymerization is used to combine monomers that have double or triple bonds. The reaction used is an addition reaction similar to what you have already studied. Here, ethene molecules are combined to create polyethene. Here are a couple of additional examples of addition polymers. Notice how the monomers have double bonds and how the polymer is a repeating chain of the monomer with the double bond removed. It is the double bond portion of the monomer that is linked together. You should be able to predict the polymer product if shown a monomer. Here, tetrafluoroethene is reacted to form a polymer. The resulting polymer would have a repeating chain with the initial polymer minus a double bond, and the halide groups that were attached to it initially. Condensation polymers are polymers that involve monomers that have more distinct functional groups. In order for condensation reactions to occur, the monomer requires a functional group at each end. Scientists have copied nature when developing certain polymers. The bonding properties of the synthetic polymers copy the bonding that exists in certain natural molecules. These synthetics are called structural analogs. For example, lipids that are fats are found in nature and are very similar to polyesters in their bonding. Nylon was developed with similar bonding to proteins, and cellulose polymers are similar to carbohydrates. Functional analogs are synthetic compounds that perform the same function as a naturally occurring substance, but may not have similarities in chemical structure. An example of this would be synthetic sweeteners. They do not have the same structure as naturally sweet carbohydrates, but they share the same function of being sweet. The first type of condensation reaction is one that can occur between carboxylic acid and an amine. This is called an amide linkage. The alcohol group of the carboxylic acid and a hydrogen from the amine are removed to release water. Where these bonds were broken, the two molecules join to form what is called an amide linkage. Proteins are naturally occurring molecules that contain these amide linkages. They are formed by combining many amino acids together into long chains. Polyamides are the polymers that are formed when a molecule has a carboxylic acid on one end and an amine on the other end. Nylon is an example of a synthetic condensation polymer that is created through amide linkages. These linkages make nylon very strong for its weight, a perfect property for creating thin fabrics that shouldn't tear easily. The reaction between carboxylic acids and alcohols to form esters can also be used to create condensation polymers. Lipids are formed by esterification reactions between glycerol and fatty acids. Examine the structures of glycerol and fatty acids shown here. Glycerol is a molecule that has several alcohol groups. Fatty acids are carboxylic acids with long carbon chains. The two molecules are able to form a triple ester in the form of triglyceride. Anytime there is an alcohol and a carboxylic acid, an esterification reaction can occur. It can occur with saturated fatty acids, and it can occur with unsaturated fatty acids. Polyesters copy these structures formed in nature to create polymers with ester linkages. This is accomplished with dicarboxylic acids and diols because they have functional groups at each end. This is considered a condensation reaction. The ester linkages would give a polymer that has alternating acid and alcohol molecules. The monomers of carbohydrates found in nature are simple sugar molecules. Sugar monomers undergo condensation reactions to form starch or cellulose with a water byproduct. Starch is a chain of repeating glucose monomers. It has linkages that form a coiled polymer. Cellulose is also a chain of repeating glucose monomers. It has linkages that form a linear polymer. Please complete the November 21st quiz.